All right, students, welcome back to Chapter 3, E-commerce, Infrastructure, the Internet, Web, and Mobile Platforms. There's going to be a lot of information in this chapter. If you don't consider yourself a computer person, a techie person, some of this might be new for you, concepts you're not truly familiar with. Don't worry, we're going to get through it. You can always ask me questions. I understand that if you have a strictly business background, not a comp-sci background, this can be a little difficult at first, but it's okay. We're going to do it together. So let's get one thing straight here from the beginning, because a lot of people think the World Wide Web and the Internet are the same thing. Sometimes we use these terms interchangeably. They're not the same. The Internet is a much larger entity than the web. The Internet is millions and millions of computers connected to each other, compromising thousands and thousands of networks, and it could even be billions of computers and millions of networks. The internet is huge, and the internet is incredibly deep. One of the most popular services that the internet can provide is the World Wide Web. Think of that as a very shallow area in the internet ocean, if you will. The World Wide Web is what you connect to. That's where you go to Google and Facebook and all these other pages that you visit on a daily basis. That is the web. That is the service that you connect to. Now, the internet has a lot of other things. There's Tor. We get into the deep web. We get into other services that your average user either A, can't get to, doesn't know how to get to, and probably doesn't even have any business being on. But the World Wide Web, the web, www. Whatever your website you're going to is, that is the most popular service, and that's what we usually think about when we think about the internet. But those terms, key terms and tricky phrases, are two separate things. If we were to define the internet, it's just a network that uses IP addressing, supports transmission control protocol, internet protocol, TCP/IP, and provides services to users. This is what makes the internet usable. We're going to go over some of these terms more in depth, so don't worry if this is new. The three most important we're going to talk about is packet switching, TCP/IP, and client server. So first off, packet switching. So think of whatever data, whatever message I want to send to you. The way packet switching works is we slice this up, that message, we slice it up into little packets. And we send those packets off different communication paths. And then they go to wherever their destination is and they're reassembled. And this goes through routers. We're not doing a point A to point B connection like circuit switching. It's much more economical and it's much quicker. Next slide here, this kind of looks like it. So here's our message. I want to communicate with you. Well, we're going to digitize that into binary zeros and ones. That's then broken down into packets. So my message, I want to communicate with you, is now broken into individual packets. That's great, but I need header information so that way when it gets to the destination, one, it goes to the correct place, but two, it can be reassembled in the correct order for my message to make sense. Transmission Control Protocol, Internet Protocol, TCP/IP. This is the communication protocol for the internet. This is how we communicate. Your TCP part, that is your connection. This is what establishes connections among sending and receiving computers on the web. Your internet protocol that's what takes care of your addressing and your delivery of the packets. There's 4 layers of this, and we'll go over these more in depth in the next slide. Alright, so let's take a look at figure 3.4 TCP/IP architecture and protocol. Let's start off with layer 1 down at the bottom, the network interface layer. This is the lowest layer. It's the protocol that is used to connect to the host or to the internet, and it varies from network to network. And what I mean by that is you might be on campus where you're using Wi-Fi or Ethernet, some sort of network there. But we have different architectures for network. It can be a token ring, it can be an ATM or a frame relay, various other different architectures that the network is built with. So that's really dependent on how that local network is. If we move up to layer 2, the internet layer, this is where we address packages and routing messages on the internet. That's what the internet layer does. It addresses them and it packs everything. This is the layer that really holds everything together. Now, remember, like we said before, the order in which the packets are received can be different from the way they're sent, and that's all taken care of in layer 2. Layer 3, the transport layer, this is where we can see different functions like multiplexing or segmenting. So we're splitting this data and sending it down the correct route or the most efficient route. It's done in this layer. And it also adds the header information to those data protocols. Layer 4, the application layer, this is where we have protocols that can provide services to users. Some of the services, and some of these have fallen, maybe may not be as popular anymore, like Telnet, for example. It's a two-way communication that allows two machines to communicate to run applications, and you can share files through Telnet, but that's really replaced with FTP, File Transfer Protocol. This allows file transfer between computer users connected over a network or directly connected over the internet. Really safe, or well, it can be safe depending on the security on it, but incredibly efficient, and it's just simple, computer to computer. Back in like the 56K dial-up days and even before, FTP was a really popular way to get files from other computers or quote-unquote servers. It was just direct, one computer going to there and FTPing it down. Now, when we're talking about maybe like some Tor files or other torrents that you would download, sometimes you're getting parts of those files from different systems. And again, that's based on what is the quickest and most efficient route to get that data to you. Sometimes it's not all from the same system, but FTP is a direct communication. Another one you might have heard of is SMTP, Simple Mail Transport Protocol. This is used to transport email between a source and a destination, usually directed by some sort of route that file would go through. Client-server computing, I'm sure you've interacted with this. You're probably interacting with it right now, where you have a personal computer, a laptop, desktop, maybe a mobile device connected to a network with servers. It could be one server, could be multiple servers. The server is storing your files. Sometimes it's storing applications that you would run directly from the server. If you're printing on a network, especially if you're on campus, you're going through a client-server connection. You're sending that file off onto the network, and it goes through a printer server, and it gets printed to whatever printer you send it to, whatever closest one. Anytime we're working in campus communities, businesses, and even some homes, you see client-server computing relationships. Just like your mailing address, your computer has address, your IP address, your internet address. It's really two standards, IPv4 and IPv6. This is the number sequence that your computer is. If I wanted to communicate with your computer, this is what I would type in if I wanted to connect to it and I had accesses on the network. IPv4 has been around for a long time. It's a 32-bit number. There's an example of it on the screen there, 4 sets of numbers marked off by periods. However, we're running out of IPv4 numbers because we block off so many of these large corporations. They need it, they use it. That limits it for everybody else and for other devices. So we've come up with IPv6. It's 128-bit addressable, so we can have a quadrillion addresses, so a large amount of computers, IoT devices, handhelds, mobiles. Just huge potential for IPv6. And a lot of that's really driven by IoT things, Internet of Devices, or Internet technology. So the idea between this, you have smart light bulbs, smart speakers, smart refrigerators. There's so many more devices being connected to the internet, and each one of those need their own IP addresses. We're running out of them with IPv4. So IPv6 handles that and gives a really elegant solution that will provide us many of addresses for years to come. Building upon IP addresses, we have DNS and URLs. There was a time many, many years ago where we didn't have websites like today. We didn't have URLs. If you wanted to connect to something, let's say it was a BBS, a bulletin board system, you would type in a phone number and your computer would call that number and you would communicate directly with the other computer. As networks grew, then you would go directly to that IP address. But the problem is IP addresses are cumbersome. They're not easy to remember. DNS and URLs are. Saying Facebook or www.facebook.com is incredibly easy. This is where the IP address is in a natural language, but that there's an IP address behind that. So you can go to the search bar in your browser and you can type in Facebook and Facebook would come up. You could type in www.facebook.com and Facebook would come up. But you can also type in 157.240.18.35 and Facebook will come up. That's the IP address for Facebook. But nobody's going to remember that. You're going to remember Facebook because that's natural language. More and more we're seeing large corporations and even individuals contain massive amounts of computing power and software from the internet. We see this through infrastructure as a service, software as a service, and platforms as a service. For infrastructure as a service, think of Amazon Web Services. So we have a massive computer infrastructure, really that can be tailored to almost any need. AWS Cloud has a government branch and a civilian branch. This can be web hosting, this can be processing power, almost unlimited potential that you can have for a fee. However, it's cheaper than if you had that server network of your own. Cloud computing is cheaper than having the servers. You don't have to maintain them, you don't have to upkeep them, you don't have to replace them. The phrase is overused and I don't like it, but cloud computing is somebody else's computer. Somebody else is maintaining and running it for you. You were just purchasing some time for it. And even some cloud computing you don't pay for. Think of the Google Suite for software as a service. If you have a Google account, a Gmail account like we do at St. Francis, you can use Google Docs, Google Sheets, Google Calendar, Google Drive. All of this is software as a service, and it's free for you to use. Now, there is a freemium version of it. If you need more storage, you can pay for that. But as is, the Google Suite is free, and it's incredibly powerful and incredibly useful. Platform as a service, these are things where IBM Cloud, so developers can build applications and they can scale them on IBM's cloud. That's great for small companies or even individual programmers because there's a lot of power behind it that they would be inaccessible to them in any other situation. But since you don't own your cloud computer, since you don't own the software or the server rather that whatever your program is running, there are some security risks for it. Do you have a secure portal to that cloud? Can you trust the company that operates that cloud? What we're seeing now is a lot of foreign state actors, instead of hacking individual organizations, they're hacking the IT support firms that manage their cloud. This is particularly prevalent on the government contractor side. So instead of hacking into BAE or General Dynamics, just find the IT firm that has 10, 12, or even more contractors on their license. If you get into their server, now you have access to 10 or 12 different companies. And it shifts a lot of the responsibility to those providers. So you're really relying on another company to make sure they maintain their servers, they upgrade their servers. If you did it all in-house, you can have an incredibly robust, reliable server that maintains all of your security requirements, but it's going to be expensive. You have to maintain that. You have to hire staff to do it. You're paying the electricity costs for these servers, hardware, software, any IT support. It becomes incredibly expensive, but there's a trade-off, and you really have to balance your security of what you're working on, the budget you have to work with, and sometimes even just the space. You might not have room in your office for racks and racks of servers. So cloud computing gives a lot of flexibility, but there's some things we need to know before we go down the cloud computing road. I really like this image as far as describing your internet network. architecture. So let's start at the top. Let's start at the backbone, right? This is the backbone of the internet. These are the fiber optic cables that transmit incredibly fast speeds, incredibly huge bandwidth all across the world, under the ocean from different continents. These are your tier 1 ISPs. There's a lot of private networks and that are connected to this, but this is really where the internet lives, and this is how the internet transmits data. But it needs to get to your home. So let's go down one level and look at our regional hubs. So that IXP there, that's Internet Exchange Protocol. This is where the tier 1 ISPs work with the tier 2. So they'll connect to it and they'll exchange information. And eventually that flows down to your tier 3 ISPs. Let's go over to the left where we see the domain NYU, so newyorkuniversity.edu. This is your CAN. CAN's a really neat acronym because it can mean Campus Area Network or Corporate Area Network, but it's a large network. It's a large amount of computers connected together, maybe even some servers and printer servers. So your regional host will break off into that domain, so nyu.edu. There's a network attached to that. All the students, all the offices, all their email servers, and there's client IP addresses for each one of those in that domain. On the other side of it, for your local ISP, going to your house, and it can go to your house through DSL, through cable, maybe satellite, maybe even 56K dial-up, depending on what part of the country you're in and what your accessibility is, or even mobile. But that goes to your home network. You're getting it through some sort of modem, and that's connecting to the outside world, and that's going to go typically to some sort of wireless router or wired router. This is where we connect all the devices in your home, and there are client IP attaches connected to each individual device. When we're in your home, we want to spread that internet out. Back in the dial-up days, that dial-up connected to one computer, and that was the end of it. We really didn't have the bandwidth to spread that out. But now that we have higher broadband access available to the home, we want to spread that out to many, many devices, dozens of devices, depending on the homes and how many people are living with it. Wireless area networks are great for that. We're taking that hardwired connection to the broadband and we're putting it out on a wireless standard, commonly known as Wi-Fi, but it's an 802.11 standard, so 802.11a, b, g, n, max, any one of these marketing terms or even standard terms. But the idea is we're getting high-speed wireless access probably throughout your entire house, depending on how large your house is. There is a limited range to wireless networks, but they're also really cheap too. So to have two wireless networks in the house, or even to have a wireless extender in the house, really won't break the bank. It's something that a lot of people do, and it's great, and it's ideal for really spreading out the internet through your house. This figure just kind of sums it up. You have the internet there, go into the wireless access point, and all these devices can connect and communicate at the same time. The great thing about this is not only can these devices communicate with the internet, but they can communicate with each other. We can do file sharing in our local network. We can set up a wireless printer, and each one of these devices can communicate with that printer wirelessly. We talked about IoT before, Internet of Things. This is a really exciting and fast-moving area of technology. But there's a lot of concerns with this when we have quote-unquote smart things. And this slide really doesn't do this justice. But when you think about it, you can go to the store, you can go to your Lowe's and Home Depot and buy a smart light bulb. Really, it's just a regular light bulb you screw into any normal light socket, but it connects to Wi-Fi. Well, why would I want that? A couple things. I can control the dimness from my phone. I can control color from my phone. Maybe I want my room to be red tonight or blue tonight. I can do all that through the app on my phone. Maybe I want that light to be a motion sensor, so when somebody walks into a room, the lights come on. There's endless possibilities for smart objects. But there's a lot of concern with that because a lot of these objects come with mics, Some come with cameras. Think of your Alexas of the world. There's a lot of security with that. There's a lot of trust. Can I trust the organization that has access to this? Can I trust that nobody else would have access to this? Is my home network strong enough to prevent somebody from going into it and listening to my conversations or watching me or getting into my home security system and disabling it when they want to get in? You think about it, a lot of home security systems now go over Wi-Fi. If they can go over Wi-Fi, it's reasonable to think, and it can happen, that somebody can sit outside on the street curb in their car and get into your network. This is just basic war driving. It still happens today, and it can be done incredibly inexpensive with not a lot of sophisticated equipment. So if you don't change your security settings, if you don't make sure you lock down your network, especially if you use a lot of IoT devices, you're really putting yourself at risk. It's great to have smart devices. It's great to have smart refrigerators, smart washing machines, but we need to make sure that the security background is really up to snuff and we're protecting our information. When broadband became more available to everyday users, this is really where Web 2.0, or the social web, is kicked off. We have different social networks: Facebook, LinkedIn, even MySpace. MySpace is really more of a music scene anymore, but it's falling out of popularity. We see a lot of blogs. We even see vlogs on YouTube where just random people are talking about their day and getting subscribers. You can even put TikTok into that category. And wikis, where any individual can add their knowledge and cite it hopefully appropriately, and put it up to anybody to read. This is the social internet. This is really the future. It's great for advertising and it's great for marketing, but we need to really understand it so we can capture it and use it for our organization. Our book really doesn't go in depth into digital assistants as much as I would like it to, but it's probably a little bit out of scope for this class. But what I want you to understand is there are a lot of different options out there. Siri, your Google Assistant, Alexa, any one of these products are out there. And it's great because it allows people to speak in natural language to a device, and that device would understand it. And I watched my wording on this, but you have a conversation with the device. I don't like saying that because what you say, the command you give it, Alexa's just giving a prompt back at you. You're not really having a conversation. It's just a bunch of verbal commands. But I do want to caution users on this because just like we talked about before, we don't really know who all has access to some of this data. Yes, we know it's either Google or Amazon, but on its way back to the servers, can some of that data be looked at? Is our privacy at risk? There's a lot of potential for this, and there's a lot of convenience in this, but users really need to be careful with it, and organizations need to put a lot of trust into it and make users trust the application to make sure they feel safe with their data. So that's going to wrap it up for this video, wrap it up for chapter 3. As always, if you have any questions, please let me know.